In this video, we are going to use what we know about finding the area of a circle, finding the area of a sector, and finding the area of a triangle to help us find what we call the segment of a circle. So as you can see, this piece right here, it does not come from the center of the circle. It is actually sliced by a segment, and this segment creates this area here, and we call that a segment of the circle. So in order to find a segment of the circle, we're going to do a couple things. We're going to find the area of the entire sector, like you see here. We're going to find the area of the entire sector. Then we're going to find the area of the triangle. We're going to subtract those two answers, and it's going to give us the area that we're looking for, which is just the piece that is cut off by the segment. So again, area of the sector, subtract the area of the triangle, and you will be left with the segment of a circle. So in this first example, you can see we broke it up into the three parts: finding the area of the entire sector, finding the area of the triangle, and finally subtracting the two and finding the area of just the segment. So in order to find the area of the sector, we're going to take the portion that we're concerned with, and I can see here that the central angle is 60. So I'm going to use 60 over 360, and I'm going to multiply it by the area of the circle, which is pi r squared. And I can see here that my r is 18. So I'm going to try and simplify it as much as possible. Again, I can cross those out. 6 over 36 gives me 1 over 6 times pi over 18 squared, and 18 times 18 is 324. So this ends up being 324 pi over 6, which simplifies down to 54 pi. And I can convert it to a decimal, which ends up being 169 and 56 inches squared. So again, either one of those would be acceptable. So that is the area of the entire sector, because again, I'm only looking for the segment of the circle, so I have to go through all of these phases first. So the second part is to find the area of just this triangle. So these are actually missing. This is congruent to that side, and this angle is congruent to that angle. And the reason that's important is because it's going to help us find the height of the triangle. And the height of the triangle only can be found by creating a perpendicular altitude, like you see here. And if these sides are congruent and this is 60 degrees, that means that these angles are also congruent. Since a triangle can only be 180, that means that all of these angles must be 60, which means that if this is 18 inches, this is 18 inches, and this is 18 inches. That's important because creating this perpendicular bisector means that this 18 now is just a 9. So this little piece right here is 9. I know that this piece here is 18, and the height of the triangle is what I'm actually looking for, so I can actually find the area. So in order to find the height, I'm going to use Pythagorean theorem, a squared plus b squared equals c squared. I know my hypotenuse is 18. I know that one of my sides is 9, and the height again is the one that I'm looking for. When I finish this out, my height ends up being about 15.5885. Now again, I did all of that because I need the area of the triangle, which the area of a triangle is base times height divided by 2. I know my base is 18, and my height I know was the 15.5885 divided by 2. My area of my triangle is approximately 140.2965 inches squared. Now the reason I'm leaving those decimals so long is because at the end I am going to round to the nearest tenth, but I like to leave the decimals as long as possible while I'm working the problem out. In this problem, I'm also going to find the area of this segment. This angle is denoted by the right angle symbol, like you see here. So again, step 1, I'm going to find the area of the sector. Step 2, I'm going to find the area of the triangle. And step 3, I'm going to subtract both those answers to find just the segment that I'm looking for. So the area of the sector is represented by the portion of the circle times the area of the circle. So I can see here, since this is a 90, I know that this is 90, so that's the portion of the circle that I'm working with. My radius in this case is 4. So that's what I'm going to use. So I'm going to simplify. I know that 9 over 36 is really 1 over 4. 4 times 4 is 16, so I end up with 16 pi over 1. This ends up giving me 16 pi over 4, which is simply just 4 pi. And of course, I can convert it to a decimal, 12.56 meters squared. So that is the area of the entire sector. Now I'm going to find the area of just the triangle. And we know the area of a triangle is base times height divided by 2. And in this case, since the angle is already perpendicular, I can use this as my base and this as my height. So I have 4 times 4 divided by 2, which gives me just 8 meters squared. So the last and final step would be to take the area of the sector, which is 12.56, and subtract the area of the triangle, which is 8, which is going to give me a final answer of 4.6 meters squared. Since the instructions say to roll to a whole number, that 6 is going to change that 4 to a 5. So there is my final answer. In this problem, I'm going to look for the area of this shaded region inside of here. First thing I notice are the congruency symbols, which are 14 inches. So I'm going to go ahead and label my shape all the way around. Because of that, I can see that this is definitely a square because they're all equal here. So in order to find the area of just this, I'm going to start by finding the area of the biggest shape, which means the area of the square, which I know is length times width. And since the length and the width are both 28, the area of my square is going to be 28 times 28, which is equal to 784 inches squared. So that is the area of the square. The next thing I notice is that the corners that I need to remove in order to find this are actually the same pieces of a circle. So if I took a circle and I divided them into 4, these 4 pieces are these same 4 pieces. So that means if I find the area of an entire circle and subtract it from the area of the entire square, I would have the portion that is left. So in order to find the area of the circle, I'm going to do pi r squared. And if this is the center, this is my radius. So my radius is 14. And 14 times 14 is 196 pi. Now, since this instruction does say leave it in terms of pi, when I take the area of my square and I subtract the area of my circle, I am going to leave it in terms of pi. So notice I am not changing pi to 3.14. So it's 784 minus 196 pi. And don't forget, inches squared. So this whole thing is my answer. And I'm just going to rewrite it one more time because I messed up.